Moving ahead, now here we have one of the most credible hypothesis which actually become a base for a Big Bang theory as well. So we have a binary star hypothesis of Russell. So in this particular theory, there has been assumption that we have three sun kind of combination, and as a result of these similar aspect which we have seen as of now with respect to the planetesimal theory and Jean and Jeffrey, there was a ejected material from the sun surface due to the gravitational pull of star, the wandering star, but here the assumptions are somewhat different. Well, so to remove the shortcoming of tidal theory, this theory was actually postulated, and now in this particular theory it has been mentioned that first of all there was a sun, and this is being known as what? Primitive sun. And along with the primitive sun, here we have a one companion star, and this companion star was actually orbiting the sun. So here we have a companion star. These two stars were there, primitive sun and companion star. Then we have a larger sun, and this sun was having a different rotational direction as that of companion star. So this sun, or you can say star, was actually bigger than that of companion star, and this is being known as what? Approaching star. Okay. Approaching star. This is being known as companion star, and we have a primitive sun. So we have a combination of three stars here. You can see primitive sun was there, companion star was revolving around the sun, and then we have a approaching star. So in this binary system 1 and 2, there was a one approaching star which actually entered the system. Now this approaching star actually directly interacted with the sun's smaller companion. So as a result of same interaction which we have discussed in the C and M theory, we have discussed in the Jean and Jeffrey's theory. So here this bigger star was there. Now when this bigger star has a nearby flyby to this CS, or let's say companion star, as a result of this, the material or the gaseous material were actually ejected from the companion star. Material was actually ejected from the companion star as this approaching star getting closer to this, and as a result of this kind of interaction, when the approaching sun was moved close towards the companion star, as a result of this, the gravitational force further increased, and that led to the tides on companion star surface similar as that of C. So when we have this companion star, and then we have this approaching star. Because the approaching star is bigger, so its gravitational pull is more. So because of the gravitational pull on the companion star, there was bulge, and ultimately there was what? Significant amount of matter was ejected from this companion star. This ejected material began to revolve around the sun. Sun is also there in this equation. I hope you remember. Sun was already there. Game of this gravitational pull and this ejection is between these two stars, companion one and approaching one. So as this ejected matter began to revolve around the sun, matter eventually cooled. This matter become cool, and that led to the formation of planets in our solar. So this is basically the binary hypothesis of this further refinement of planetesimal theory, or the further, we can say, the cause which has been tried to be explained by Jean and Jeffrey theory were further validated by binary star hypothesis of Russell. So this is the crux. It's see. So in the binary star hypothesis, we had a combination of three stars. One was sun, another one was the companion star, and the third one is wandering or approaching star. Now this wandering sun or approaching star pull the filaments from companion, and as a result of this, the filament captured by the sun pulls, and as a result of condensation, planets were. Now this theory also owns some sort of limitations. Disappearance of companion star. Yes, there was some sort of ejection of material from companion star, but that doesn't mean that companion star is completely decayed. So like there was, lastly we have a two sun in their existence. So there was a lack of clarity on the disappearance of companion star here. Then we have a planetary spacing, the space which you see nowadays among these planets. Now the spacing of planets is not justified by this particular, or let's say it's not addressed by this particular. Planetary spacing is also one of the limitation which actually make this theory less credible. Then we have a orbital mechanics paradox, that how the ejected material which was suspended in space, how that becomes cool and how that started to orbit around the sun because of the gravitational pull of sun. On the one side you are saying that wandering or approaching a star have a more gravitational pull as compared to the companion one or sun, or let's say our primitive sun. But on the another side, there has been mentioning that when the filaments or the ejected material was there from the companion star, it started to orbit around the primitive sun. It's because of the gravitational pull of sun itself. So there is some sort of, we can say, paradox here. The orbital mechanics paradox is also one of the limitation which actually make this theory less credible.